What if everything you know is wrong?
You know, it feels like every single week there's a new AI coding model that drops, right? And they all claim to be the fastest, the smartest, the undisputed champion. It's this insane race between massive companies and these scrappy open source projects, all fighting for the top spot. But with all these different claims flying around, how do you actually know who's winning? Well, let's dive in and try to figure that out. All right, so in one corner, we've got the new heavyweight from Anthropic, Claude Opus 4.6. This thing is boasting state-of-the-art performance and a truly colossal 1 million token context window. Then, in the other corner, you have this disruptive open-source challenger, GLM 4.7, and it's coming in at just a tiny fraction of the cost. I mean, it's the classic battle, isn't it? The closed-off proprietary giant versus the accessible, community-driven powerhouse.
Okay, so how do these models try to prove they're the best in the first place? Well, it all starts with winning on paper. They do this through a series of standardized tests. You've probably heard of them. They're called benchmarks.
And let me tell you, Claude Opus 4.6 comes out swinging. According to Anthropic, it's leading the pack in what's called agentic coding. Now, what that really means is it can act like its own autonomous assistant, handling complex, multi-step tasks all by itself. It also reportedly just crushes GPT 5.2 when it comes to financial and legal analysis, and it shows some really impressive recall over massive documents. These are the kinds of numbers that make big companies and serious developers sit up and pay very close attention.
But the real headline feature, the thing that gets everyone talking, is this: a 1 million token context window. And that is a total game changer. What it means is the model can process and reason over an entire massive code base all at once without losing track of what it was doing. Just think about that. It's like having a perfect photographic memory for your entire project.
But wait a minute, because the open source contender, GLM 4.7, is not backing down. Now, what's so interesting here is just how close these numbers are. Yeah, Claude is a little bit ahead on one benchmark, but then GLM 4.7 actually pulls ahead and beats a comparable Claude model on another one, Live Code Bench, and also in tool use. This is huge. It shows that open source isn't just playing catch-up anymore, it is genuinely competing at the absolute highest level.
And it has a kind of secret weapon. It's a feature they call preserved thinking. See, with most models, they have to completely rethink their strategy with every single message you send. But GLM 4.7, it's different. It actually remembers why it made certain decisions earlier in the conversation. And that is absolutely massive for preventing dumb errors and just staying consistent during those really long, complex coding sessions that might stretch over days. So, okay, we've got two champions, right? Both with really impressive scores. It kind of looks like a dead heat. But this brings us to a much, much more important question. Are these tests, these benchmarks, even the right way to be measuring success in the first place? I mean, what if the entire game is flawed? Not because of the players, but because of the rules themselves. Well, according to a new research paper about a benchmark called OSS Bench, there are some pretty big problems here. See, a lot of the standard tests are static, which basically means models can just memorize the answers over time. They often use really simple challenges that don't look anything like the messy, complicated reality of software development. And maybe worst of all, they almost completely ignore one of the most critical parts of coding, security.
The researchers put it pretty bluntly. They say that with AI assistants becoming so common, there's now an urgent need for rigorous and robust evaluation. Bottom line, we just need a better way to test these things.
And that is exactly what this new research is all about. They're proposing something new. Not another sterile lab test, but a true, real-world gauntlet.
So, let me introduce you to OSS Bench. The idea behind it is so simple, but it's absolutely brilliant. Instead of giving an AI some small, isolated puzzle to solve, you tell it to go edit a function inside a massive, complex, real-world project. We're talking about things like the PHP interpreter or the SQLite database engine. And then you just see if the whole thing still works. And this right here shows you exactly how it works. The AI generates a piece of code, right? That code gets dropped directly into the project source files, and then it gets put through the exact same development pipeline that a human engineer's code would face. No shortcuts, no special treatment. It has to play by the real rules. And to pass, the code has to survive 3 brutal trials. First up, compilability. After you make your change, does the entire million-line project even build without errors? Second, the functional test. Does it pass the thousands of tests that the project's own developers wrote to make sure everything works? And third, memory safety. Did your so-called improvement just introduce a catastrophic security vulnerability, like a buffer overflow?
So, what happens when you actually put these top AI models through a realistic test like this? Well, the results, they completely flip our understanding of what it even means to win this race. All of a sudden, that leaderboard we thought we knew gets totally scrambled. The biggest, most powerful models, they don't just automatically take first place anymore.
Okay, let's get to the results because this is where the story gets really fascinating. Just look at this table from the OSS bench paper. You see the Qwen 3 model? It only has 8 billion parameters, and it scores a pretty solid 65.4. Now look down at the Code Llama model at the bottom. It's a monster, a massive 70 billion parameter model, and its score? A measly 27.8. This is proof positive that in a real-world test, bigger is definitely not always better.
So the key takeaway here is this, and the researchers just nail it with this quote. Model size does not reliably predict performance. Architecture and training strategy matter more. In other words, a smarter, more thoughtfully trained model can absolutely run circles around a bigger, brute force one when you put them in the real world.
But honestly, that wasn't even the most important finding. No, the most alarming discovery came from that third trial we talked about, memory safety.
736. Just let that sink in. That's the number of new security bugs introduced by just one of the top open source models after its so-called improvements were stress tested. For comparison, the original human-written code, it only had 56 bugs under the exact same test. The AI didn't just fail to fix things. It made the code dramatically, terrifyingly more dangerous.
And this wasn't just a fluke, a one-time thing. It was a consistent pattern. The paper concludes that even when you specifically tell the models to focus on safety, their code still introduces roughly 10 times more security violations than the original code they were supposed to be fixing.
So all of this leaves us with a really critical question, doesn't it? We are getting incredibly good at building powerful AI that can write code. There's no doubt about that. But as these models get woven deeper and deeper into our digital world, maybe the real challenge isn't just about making them more capable. Maybe the real challenge is figuring out how, and more importantly, when, we can actually trust the code they write.
Understanding begins with why.